So hey guys, hello and welcome to my channel. So today we'll be discussing about the real numbers. So before we'll be discussing about the real numbers, so let us go little bit backward and let us know what is counting numbers, what is a whole number, what is integers, what are rational numbers and what are irrational numbers. So very good. So now I know the numbers like 1, 2, 3, 4 and so on. So these are called my counting numbers or natural numbers. So these are denoted by n. Then next, if I am adding another number that is 0 in this set of natural numbers, of this collection of natural numbers, I will be getting 0, 1, 2 and so on. So now this will be my whole numbers. And it is denoted by W. So similarly, if I will be including negative natural numbers, that is -1, -2, -3 and so on, so I will be getting these three collections. If I will be make the collection of these three set of numbers, so I will be getting the set of integers, so that I will be denoting as Z. So these are my integers. So next, after knowing what are integers, so integer means they are natural numbers, or they may be 0, or it may be the negative natural numbers. So fine. After this, so let us take one set, or I am considering a collection, that is I am denoting it as Q. Let this be equals to the numbers in the term P by Q, where P and Q belongs to this set of integers and this Q is not equals to 0. So now this set of numbers, are called my rational numbers. So let us take some examples. So I will be saying, okay, 5 by 3. Yes, this is in terms of P by Q, where P is 5 and Q is 3, and Q is obviously not equals to 0. So P 5 by 3, that is a rational number. So similarly, 1 by 2, this is a rational number. 2 by 4, this is also a rational number, and so on. Now, when I will be saying it is a rational number, then I am just one step behind to this set of real numbers. So what is that step? So then I will be saying there are some numbers that cannot be represented in the term of P by Q. So I will be saying that numbers are, for example, it is √2, √3, √5 and so on. Okay, so actually we will be differentiating this rational number and irrational number by taking some examples in the next class or in later classes. So now, but for the time being, this will be the terms that is in terms of P by Q, that will be my rational numbers, and the numbers that are not represented in terms of P by Q, that are called my irrational numbers. So fine, here is one thing. So can I say 2 is a rational number? The answer is yes, because I can write that 2 was, it is by 2 by 1. Okay, so that means these all natural numbers, they are included in the rational numbers. So similarly, can I say 0 is in the set of rational numbers? So the answer is yes. So I can write 0 by 1 or 0 by 2 or anything like that. So I can write it as 0. So obviously 0 is inside the set of rational numbers. So next, can I say -5 is in this set of rational numbers? The answer is yes. Again, how? So I will be saying, okay, let us take 5 by -1. So obviously this is -5. So now where P is 5 and Q is -1. So similarly I can say -5 by 1. Is that clear? So I can say -5 by 1. So here Q is 1 and -5 is P. Okay, so fine. Here actually these are two numbers, but I will be saying these two numbers are equal because Because I can say, or let us take some another example. I will be saying 1 by 2 and 2 by 4. So are these two numbers equal? So the answer is yes, these are equal. So actually 1 by 2 is the reducible form of this fraction or of this rational number. That means if there is any common terms in between p and q, I will just cancel it out. Cancel it out means I will be just dividing the same number in the numerator and in denominator so that I can get the term in the reducible form. So when can I say a number is in terms of reducible form? So obviously I can say p by q, it is the reducible form, or it is in the reducible form if pq, the HCF of pq is 1. That means if p and q are co-primes. So what is the meaning of HCF? HCF means it is called the highest common factor. Okay, so we'll be also discussing about this highest common factors, but for now, so these are my integers. From these integers I am getting the rational numbers. From these rational numbers, the numbers that are not included in the rational numbers, that are called the irrational numbers, and including these, that means obviously, so I can say all z are in this Q. So if I will be considering this, the rational numbers as well as the irrational numbers, so I will be getting another set that is called the set of real numbers. Okay, so this is called the set of real numbers and it is denoted by R. So now we have put the step into the set of real numbers. So fine. So next, actually in the set of real numbers, we will be discussing something about Euclid's. Okay, let me. Okay. So let me say what we will be discussing in this real number chapter. So here we have actually introduced, or we have actually discussed the introduction part. So now we will see the second part, that is called the Euclid's division lemma. Then we will see the fundamental theorem of arithmetic. Next, we will take a dip into the irrational numbers. Then to rational numbers. Next, we will be seeing the decimal representation of these rational and irrational numbers. Okay, so fine. So let us start. What is Euclid's division lemma? So Euclid's division lemma says, so now Euclid's division lemma says, given any positive number a and b, we have whole number q and r such that a can be written as bq plus r, where this r is in between 0 and b. So this is my statement for the Euclid's division lemma. So actually we will be using this lemma to find the HCF of any two numbers. Okay, HCF of any two numbers. So here, so what does this Euclid's lemma says? It says if I am having any two numbers, so let us consider I am having 25 and 26. So I can always say, I can write 25 and 26 in a relation such that 25 is equals to 26 into 0 plus 25. Okay, so here this 0 is my Q, this is my R, and this is my B, this is my A. But if I will be saying, okay, this 26 is my A and 25 is my B, then I can write 26 is equals to 25 into 1 plus 1. That means here this is my A, this is my B, this is my Q, and this is my R. So in both the cases you will be seeing, so here 0 will be less than equals to R, that is less than equals to 26, and here 0 is less than equals to R, that is less than 25. Is it clear? So that's great. So now, before going to this, using this Euclid's division lemma to solve the SF and LCM of any two positive numbers, so let us consider a riddle. So actually it is in the book. So let us have a look on the riddle. Okay. So actually the riddle says a trader who sells egg. Okay, a trader who sells egg came in contact with an adler. So and that contact comes to a worldly duel. So in that moment, the adler actually it destroys the trader's egg, which was actually bought for the sale. Okay, so now the trader came into a great trouble. So he goes to the panchayat and tells that actually this adler, he broke all my eggs that was for the sale. Now please give me the compensation and solve my problem. So the panchayat asks, okay fine, we will be solving your problem, but how much egg do you have with you? Okay, so the trader says, if I will be counting my eggs in twos, then I will be having one left with me. That means if I will be counting the eggs in twos, I will be having one with me. If I will count that in threes, I will have two with me. If in fours, I will have three with me. Likewise, if I will be counting it in fives, so 4 will be with me. Next, if I will count with 6, so 5 will be remaining with me. And if I will count it within 7, so 6 will left with me. And sorry, so nothing will left with me. So next, and the maximum number of eggs, it cannot exceed 150x. So how to solve the puzzle or how to solve the riddle so that we can come to the conclusion. So conclusion that actually how many eggs the trader has. Okay, so let us solve this by using the trial and error method. So trial and error method means first of all we will be considering the possible number of eggs that trader had. So let us consider first the last one, that is it is actually the eggs that are the multiple of 7s. So first of all we will consider all the numbers that are multiple of 7 and that is less than or equals to 150. So let us consider that. So it will be 7, 14, 21, 28, then 35, then 42, then 49, then I am having 56, so 63, 70, then 77, 84, then 91, so next it will be 98, next 105, next 112, 119, next it is 126, next 131, sorry it is 133, next 140, then 147, then okay, so the last term it will be 147. Now we will be just eliminating the terms by using the other conditions. So first of all, it says if I will be dividing the number of egg in twos, so I will be having one egg left with me. That means the number cannot be a multiplier of 2 or it cannot be divisible by 2. So fine, let us eliminate all the terms that are divisible by 2. That means that are even numbers. So I will eliminate this. Okay, so that is fine. So next, I am saying the number, if I will divide this number of eggs in threes, I will have 2 eggs with me. So now that means it is not divisible by 3. Okay, it is not divisible by 3. So let us first eliminate those terms that are divisible by 3. Okay, so obviously this is divisible by 3. Then this is divisible by 3. This is divisible by 3. So this is divisible by 3. Now let us consider the numbers that are divisible by 4. So actually here there are no numbers that are divisible by 4 because if the number that is divisible by 4, so it is also divisible by 2. So I have eliminated the terms that is divisible by 2. So next we will be considering, okay, let us see. So the next condition is that if I will divide this by 3, then I will have remainder 2. So first, if I will divide this by 3, so 7 when it will be divided by 3, so it will be giving me 6, it will be giving me 2 and it will leave a remainder 1. So this is not possible by this condition. Okay, then similarly second, so 35. If it is divided by 3, so 1, so this will be 5, so 3 1 3 2. So it may be a possibility. Okay, it may be a possibility. So now if I will be considering 49, so if I will be considering 49, so that means when it will be divisible by 3, so 3 1 3, 1 9, so 6 18, so 1. So this is not a possibility. Okay. Next, 77. So if I will divide 77 by 3, so it will be giving me 3 2 6, 1 7, so 3 5 15, so 2. So it may be a possibility. It may be a possibility. Okay. So likewise, if I will be saying 91 when it will be divisible by 3, so 9, so 1 30. Okay. So when it will be divisible by 30, that means I will be leaving the remainder 1. So 91 is not the possible term. So likewise, if I will be considering 119, so if I will be considering 119, it is divisible by 3. So if I will divide this by 3, so 3 3 is a 9. So 2 9, 9 is 27. So it is 2. So it may be a possibility. Okay, then next 133. So 133, if it is, I will divide this by 3, so it will be 3 3 4 12. So 1 3, so 3 4 12, so 1 left. So it cannot be a possibility. Okay, because I am having, if I will divisible by 3, or if I will divide this by 3, then I will be leaving the remainder 2. But here I am getting the remainder 1. So now, so how many terms we have now? So this 35, 77 and 119. So from these 3 terms, there may be one term so that I can obtain the number of eggs the Pritam has. Okay, so now, so 35. So next, if it is divisible by, if I divide 35 by 4, then it will leave the remainder 3. So let us see. So 35, when it is divided by 4, so 32. So it leaves the remainder 3. Okay, it may be a possibility again. So 77. If 77, I will divide this by 4. So 4 under 4. So 3 7. So 1. So it cannot be a possibility. Okay. So I am 190. So you can see 119 when it is divisible by 4. So I will be getting 4 to the 8. So 39. So okay. So it may be also be a possibility. Okay. So next we will be considering for 5s. So if it is divisible by 5, then I will have the remainder 4. But if I will divide 35 by 5, then it will leave the remainder 0. So it cannot be the possibility. Okay. So next we will see for 119. So 119, if I will divide this by 5, then I will be getting 5 to the 10. So 2 9. Okay. So 2 9. So 5 5 is 25. So it is giving me the remainder 4. Okay. So next the last one. So if 119 it is divided by 6. So 119 when it is divided by 6. So I will be getting 6 1 is 6. So 5 9 to be 4. So 5. Okay. So actually this 119 it satisfies all these conditions. Okay. So it satisfies all the conditions. That is why I will be saying okay, the trader has 190x with him. So the trader will have to pay for 190x. So fine. Actually here I have used a little bit concept of Euclid's division lemma. How? So here what I am saying, let us consider this 190. Okay, so let us consider this 190. So have I told that 119 is the required answer. So 119 that can be written as 2 into 2 into 5 9 plus 1. Okay. So next 119 it can be written as 3 into okay. So similarly 119 can be written as 4 into is that clear? So similarly I can say 119 can be written as 7 into is that clear? Okay, so I can say 190, I can write 190 in this term. So if I will be saying if I am having two numbers 2 and 190, so how can I write 190 in terms of 2's? So I can write okay 190, I can write this in this form. So this is actually a particular case of the Euclid's division lemma. Okay, so it is a particular case of Euclid's division lemma. So fine. So as I have told you that but actually Euclid's division lemma says, so it says as for any two numbers or for any two positive numbers, so more particularly for any two positive numbers a and b, I am having, I will always have whole numbers p, q and r, some q or r such that I can write a is equals to bq plus r. Okay, and this r is in between 0 and b. Fine. So this r is in between 0 and b. So now how can I use this concept to find the HCF of any two numbers? Is that clear? So how can I find the HCF of any two numbers? So let us consider these two numbers a and b. So how can I find the HCF of these two numbers? So actually you will be using three steps to find the HCF of a and b. So how can I find that? So let us first see a is greater than b or a is less than b. Okay, so suppose a is greater than b, then I will say I will divide a by b so that I can get a quotient Q and a remainder R. Okay, so that means I can write A is equals to BQ plus R. Okay, next, so what is the possibility for R? So the possibility for R is in between 0 and B. Is that clear? So next, if R is equals to 0, that means A is equals to BQ, and that means the HCF of AB is equals to B. Now, if so, this is my first step. So next, second step. Okay, if R is not equals to 0. Okay, if R is not equals to 0, then we will use the Euclid's lemma for B and R. Okay, we will find the Euclid's we will use the Euclid's lemma for B and R, so that I can get B is equals to some R into Q1 plus some R1. Okay, R into Q1 plus some R1. Again, I will follow the second step such that I will be saying, okay, if R1 is equals to 0, then R is the HCF for A and B. Then R is the HCF for A and B, because I will be using the concept HCF of AB is equals to HCF of BR. Okay, actually it is the concept that we have read in earlier classes. So I will be using this concept to find the HCF of these two numbers. So let us take one example so that you will be clear how to find the HCF of any two positive numbers. So fine. Okay. Let us say one is 149, another one is 32. Okay. So I am considering two numbers. So first of all I will see which one is greater and which one is lesser. So obviously this is 149 is greater than 100, it is greater than 32. So now this will be my B and this will be my A. So what will I do? I will divide 32 by, I will divide 149 by 32. Okay, I will divide 149 by 32 so that I can get okay, so it will be 32 4 jar 128. So 1. So this is 2. Okay, 21. So that means I am saying I can write 149 is equals to 32 into 4 plus 21. And obviously this 21, this is greater than 0 and it is less than 32. So next, actually this is not equals to 0. So this is not equals to 0. That means I will be considering the second step, that is I will be using the HCF of, or I will be using the Euclid's lemma for 32 and 21. Again I will see, so which one is greater and which one is smaller. So obviously 32 is greater than 21. Next, so what I will do? I will be dividing 32 by 21. So that I can get, so if it is divisible by 21, so I will be getting 21 1 21, so 1 1. Okay, so next, again I can say 31, it can be written as 21 into 1 plus 11. Again 11 is not equals to 0, so again I will consider the step that I will find I will use the Euclid's lemma for 21 and 11. Okay, I will use the Euclid's lemma for 21 and 11. So now again 21 is greater than 11. So I can write 21 is equals to 11 into 1 plus 10. Okay. So again, because this is not equals to 0, so again I will use the Euclid division lemma for find for these numbers 11 and 10. Okay, next. So it will be I can write 11 is equals to 10 into 1 plus 1. Okay, 10 into 1 plus 1. So again this is not equals to 0. So again I will go to the step that I will be using the Euclid division lemma for 10 and 1. Okay, for 10 and 1. So now 10 I can write as 1 into 10 plus 0. Okay, so now I get it equals to 0. That means the HCF will be the previous, or it will be the divisor for this case. That means HCF of 149 and 32 is equals to 1. Okay, so actually I think you may be knowing one thing that is called the long division method. So how we can find that use the HCF and LCM by using the long division method. So it is somehow similar to that long division method. Okay, so you can consider or some other examples, and in the next class actually we will be discussing some more thing about the on the concept of Euclid's division lemma, and then after we will be going to find to give the statement of fundamental theorem of arithmetic, and using that fundamental theorem of arithmetic we will solve some more problems. Okay, thank you.